Hello, I am Boyan Wang from Gachon University. I will make a presentation for novel methodology for forecasting business cycles using ARIMA and neural network with weighted fuzzy membership function. I will proceed as following order. In the field of economy, it is very important to forecast various sectors for economy. In order to forecast a business cycle, we proposed a model that combines ARIMA UFM. We used 7 items of the leading composite index as dataset. Prediction performance was improved due to the proposed model. Business cycle forecasting captures the cyclic pattern of changing economic situations using observed economic data and forecasts future economic fluctuations. Many linear and nonlinear forecasting models have been introduced. Some studies forecast the business cycle by using or applying traditional probability and statistical techniques. However, these methods are not efficient in forecasting the business cycle using time series data and only predict the short-term index. Research on linear and nonlinear prediction models was conducted while reflecting the time series characteristics, and models such as SVR, fuzzy, neural network, and ARIMA were used. In this study, a hybrid forecasting approach combining ARIMA and UFM is proposed. ARIMA has been used for traditional econometric time series analysis. In ARIMA, the type of the autoregressive and moving average parts are combined. ARIMA refines the time series by reducing the noise of the data, thereby enhancing the classification rate. However, it is limitations as a linear model for dealing with chaotic economic data. UFM is an algorithm that assigns weights to fuzzy membership function and runs the weights in a similar way to neural network. To improve the prediction accuracy, the time series preprocessed by ARIMA were used as input vectors to the UFM. In this paper, the performance of classification and prediction was compared between a method using ARIMA and a method using both ARIMA and UFM. The method using ARIMA and UFM together obtained 91.61% as accuracy and outperformed ARIMA in both classification and prediction. I will introduce dataset which we use for experiment. The 7 components of the LCI, such as jobs, production, and consumption, were used as a dataset. These indices indicated signals of good or bad differently for each specific economic field earlier than the GDP compilation by the Statistical Authority as shown in Figure 1. The red dotted line shows the economic situation in advance for the blue solid line in Figure 1. The monthly observation data sets for 180 months from January 1991 to December 2005 were used for training, whereas the monthly data during the 12 months of the following year were used as test data for outlook. GDP is used as the target in the learning process of neural networks, and the function is performed to classify the category of the economic phase into true class 0 and peak class 1 as presented in Table 1. I will explain proposed methodology from now on. We made 2 kinds of experiments. One is to forecast business cycle only using ARIMA. The other is the forecast business cycle ARIMA new FM model. The first is about classification of a business cycle using only ARIMA. At first, I will explain characteristics of the ARIMA model. ARIMA is a widely used tool to analyze time series data such as a business cycle. ARIMA fits a non-stationary dataset into a stationary dataset using a noise filtering function. The ARIMA model comprises three parts as following. First, the autoregressive AR part. Second, the moving average MA part. Third is integrating side I. So, ARIMA. Next, I will explain implementation of the ARIMA model using Minitab software. The Minitab software was used to fit the ARIMA model's time series. Minitab suggests appropriate time lags of autocorrelation and its own time series. Left side picture is to analyze through Minitab, and then through correlation analysis, lag is selected like this. Lag is selected as shown right side picture. After an iterative experimental process to determine the parameters through Minitab software, the ARIMA 1.1.3 model was selected. 1 means a time lag of order 1. This 1 means difference of order 1. And 3 means MA of order 3. Forecasting result was shown in Table 3. Training accuracy was 83.79. Testing accuracy was 83.33. Second, I will explain ARIMA new FM model. In ARIMA new FM, the new FM is a synthesized type of fuzzy logic and neural network that performs supervisory learning. The preprocessed values of the time series produced by the ARIMA 1.1.3 model were used as input vectors to the new FM. In Figure 6, from here to here is new FM part. New FM is composed input part, fuzzy part, and output part. Fuzzy part has many weights, and during learning time, these weights are adjusted. Both the prediction and classification are possible through new FM. This page includes classification result using ARIMA new FM model. ARIMA 1.1.3 model also was used in classification using ARIMA new FM model. Table 4 shows result. Both training and test accuracy were 91.261%. In addition to classification, prediction experiments were also performed. We used the sum of squared error to measure predictive performance. Error rate was 2.0471% for the ARIMA new FM model. Next, comparison and discussion. ARIMA's effectiveness on non-stationary dataset is limited. ARIMA new FM combining the two models can significantly enhance the classification rate, thereby increasing the approximation performance with GDP as in Table 5. In Table 5, ARIMA new FM model showed better performance than ARIMA model. For linear regression, the time series processed by ARIMA and ARIMA-NUFM were used as predictors, whereas those of GDP were used as response variables. In Table 6, approximation performance of 71% for ARIMA-NUFM model in terms of coefficient of determination was higher than that of 69.1% for the ARIMA model. However, the error rate for ARIMA-NUFM model was less than ARIMA model. Finally, we'll reach conclusion. This study investigated a novel methodology for forecasting business cycles using ARIMA and NUFM. This new approach enhanced the advantages of both models to obtain a significantly improved classification rate, thereby increasing the approximation performance with GDP as well. Using this model, the components of LCIs successfully integrated different good or bad signals into a single indicator and provided an early indicator of a comprehensive business cycle, admirably fitted as GDP, which requires a considerably time lag for compilation. Consequently, the ARIMA-NUFM model presents another method for forecasting the business cycle for developing economic plans or strategies in advance for enterprises and governments. Further, experiments using different data sets that are sufficiently long to cover the lost time series in adjusting and smoothing process of the time series by ARIMA are required. I will conclude the presentation. Thank you for listening.